Good morning, everyone, and welcome to today's first SASA launch to Mars. The payload for today's mission is RedScope-1 satellite, which is a cutting-edge satellite that will redefine how we study the red planet. This satellite is a giant leap forward in understanding Mars's surface, its weather patterns, and the presence of ice. Over the next few minutes, we'll talk more about this amazing satellite manufactured by Interplanet Researches, so stay tuned. Let's start by talking about what is RedScope-1 and why is it so important. This advanced observational satellite is packed with instruments capable of mapping the Martian surface in 8K, but these high-resolution images need to come back to Earth after they are stored on the satellite. This is why this satellite is equipped with Commulinks antennas. Also, with its high-resolution imaging systems, RedScope-1 can reveal textures and features down to the smallest scales, helping scientists identify minerals, geological structures, and even signs of ice. But that's not all. RedScope-1 is also equipped to study Mars's weather and climate. It will monitor dust storms, seasonal changes, and temperature patterns, giving us a better understanding of the planet's atmosphere. Now let's talk about RedScope's equipments. This satellite has two high-resolution cameras that can offer images that will revolutionize our understanding of Mars's geology. Spectroscopy instruments that can analyze the light reflected off the surface to determine the composition of rocks. And the last but not least is its integrated artificial intelligence. RedScope-1 isn't just observing, it is thinking. With AI, the satellite can adapt to real-time conditions, focusing its instruments on areas of high scientific interest. These instruments are powered by two giant solar panels on the sides of the satellite. Now let's talk about today's launch. RedScope-1 will launch on board a Flaming Tiger Block 4, which is a two-stage rocket with 9 engines powering the first stage and 1 engine powering the second stage. After SECO, Flaming Tiger will wait until the moment for it to do its trans-Mars burn.
Engine chill has started.
This trans-Mars burn will last for approximately 3 minutes, and then Flaming Tiger will only relight its engines 6 months later, when it reaches Mars. Another thing that will happen on today's launch is an RTLS landing, which stands for Return to the Launch Site. RedScope-1 is a heavy satellite, but will push Flaming Tiger to its limit to see if it can perform an RTLS landing while carrying this much weight. We're approaching the T-5 minutes mark on the countdown. The next major events will be Stage 1 and Stage 2 prop load finish, which will happen at T-3 minutes and T-2 minutes respectively. After this, we'll have startup followed by go or no-go for launch. Also, it's important to note that all experiments from RedScope-1 will be published globally to accelerate progress in planetary science. Today we're launching from Launch Complex 39A at Kennedy Space Center. This webcast will go until parking orbit insertion, and a video from the trans-Mars burn will be posted on Twitter.
Stage 1 prop load is complete.
Good call out there. The first stage is now fully loaded ahead of launch.
Stage 2 prop load is complete.
The second stage is fully loaded. Now let's listen into the terminal count.
Tanks are pressurizing ahead of strong back retract. Startup. Strong back retract. We're go for launch. T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of Flaming Tiger. Go SASA. Go Flaming Tiger. Stage 1 chamber pressure is nominal. Flaming Tiger is pitching downrange. Flaming Tiger trajectory is nominal.
We're 30 seconds into flight. All 9 engines working nominally as you can see, and the craft is currently doing its gravity turn.
Max Q.
We've just passed through the 1 minutes into flight mark, and Flaming Tiger has passed through Max Q. Max Q is the moment when the dynamic pressure outside the rocket reaches its peak.
Vac engine chill.
Coming soon will be 6 events in rapid succession. They are MECO, stage separation, second stage engine ignition, first stage flip, fairing separation and boost back burn.
MECO. Stage separation confirmed. Vac engine ignition. First stage flip. Fairing separation confirmed. Stage to chamber pressure is nominal. Boost back burn ignition.
Amazing! We've passed through the stage separation maneuver. Now the first stage is coming back to Kennedy Space Center to attempt an RTLS landing while the second stage is burning into a parking orbit.
Boost back burn shut down. Both stages' trajectories are nominal. We're go for landing. Entry burn. Entry burn shut down. SECO. Nominal parking orbit insertion. Landing burn.
And there's the sonic boom coming through my microphone.
We're now down to one engine. Landing legs deployed. The Infinity Ascender booster has landed on landing zone 1. Vehicle safing operations have started.
What an amazing landing! Even though we were pushing it to its limit, it still successfully landed on landing zone 1. Thank you everyone for watching. For additional imagery of this launch, follow us on Twitter or join our Discord community. Goodbye and see you on the next launch.